Hi, I am Sam, your teacher, Sam, my teacher, Sammy teacher. Every math teacher emphasizes the importance of the Pythagorean theorem, and it is important. You may already know what it is, but let me briefly state what the theorem says. For any right triangle, you have two legs that form 90 degrees, which is a right angle. And at the opposite side of the right angle, you have a hypotenuse, which is the longest side of a right triangle. And the squared value of the hypotenuse, which is c squared, will always equal the sum of the squares of the legs, a squared, b squared. And that's the Pythagorean theorem. But is there any way to prove the theorem? Actually, there are several different ways to prove it. And in this video, I want to show you one of them. I cut out a right triangle from a colored paper and took a photo of it with my cell phone. I labeled the legs with small a and b, and I labeled the hypotenuse with small c. I also marked the right angle with perpendicular sign and labeled the other two angles with capital A and capital B. By the way, angle A and angle B add up to 90 degrees because the sum of the three angles of any triangles add up to 180 degrees. And if you subtract this right angle from 180 degrees, that leaves 90 degrees for the other two angles. So keep this in mind. The two smaller angles of a right triangle, angle A and angle B, add up to 90 degrees. Now, I cut out three more right triangles using different colors. So now I have four right triangles altogether. They all have same angles and they all have same side lengths. So we can say they are congruent triangles, which means they are identical to each other. And of course, their areas will be the same. Now, I'm gonna rearrange these triangles to make a certain shape. And here it is. This colorful figure turns out to be a square, missing a smaller square in the middle. How do we know they're squares? Anyway, remember I told you angle A and angle B add up to 90 degrees? Since this angle is angle B as well, and you have angle A here again, they will add up to 90 degrees as well. And same thing for these two corners. And look at the exterior sides of this figure. As you can see, they are all C's because each of them is the hypotenuse of the four congruent right triangles. The angles are all 90 degrees and it has four equal sides, so it has to be a square. And what about the empty region in the middle? This leg minus this leg, which is B minus A, will be this side. And again, it's B minus A, and same thing for the other sides. And if you subtract this right angle from the straight angle, which is 180 degrees, since 180 minus 90 is 90 degrees, we know this is 90 degrees as well. And same thing for the other angles. So we know the empty region in the middle is a square too. Now, what I'm going to do is find the area of this colorful figure. And I see two different ways of finding the area. First, I can find the area of the larger square and subtract the missing square in the middle. And the second method will be finding the area of one of the 4 congruent right triangles and multiply that by 4 because there are 4 of them. Either method will give you the same area. Using the first method, the area of the bigger square will be c times c. So it's c squared. And the area of the smaller square will be b minus a times b minus a. So it will be b minus a squared. So this is the expression for finding the area of the the colorful figure using the first method. Now I'm gonna expand this part of the expression. Since square root of a base means multiply the base twice, I can rewrite it as b minus a times same thing, b minus a. And I can simply copy down the rest and put it equal to each other. Next, I'm going to distribute this part by FOIL, which means fronts, outsides, insides, and lasts. So the fronts multiply to be b squared, and outsides multiply to be negative ab, and the insides multiply to be another negative ab, and the lasts multiply to be plus a squared, because negative times negative is positive. And again, I'll copy down the rest and put an equal sign. Now, these two are like terms and they can be combined. And they are combined to be negative 2ab. So I simplified the above expression a little bit. Now, I'm going to try to take these three terms out of the parentheses, but we have to be careful because this negative sign will change the term to opposite signs. So the whole thing will equal c squared minus b squared plus 2ab and minus a squared. So this is the expression for the area of the colorful figure using the first method. Now, using the second method, since 1/2 times base times height gives you the area of any triangle, and for a right triangle, the legs can be the base and height, 1/2 times base times height, which is 1/2 AB, will give you the area of the right triangle. And let us not forget to multiply that by 4, because there are 4 of them. And you can see that this number in the denominator reduces this number, leaving 2. And by multiplying what still remain, we finally have 2ab, which is the expression for the whole colorful figure using the second method. These two expressions look different because I used two different methods. But don't forget that they do represent the same area, which is this. So I can come up with this equation, c squared minus b squared plus 2ab minus a squared, which is exactly this, and put it equal to 2ab, which is exactly this. And in order to make this equation look a little simpler, I can subtract 2ab from the left side of the equation and subtract the same thing from the right side of the equation as well, which will cancel these terms away. And that leaves c squared minus b squared minus a squared on the left side of the equation, and it leaves nothing on the right side of the equation. Now we are starting to see something familiar to us. That means we are almost done. Now I'm going to add a squared on both sides of the equation to remove this term from the left, and add b squared on both sides so that I can eliminate this term as well. And finally, that leaves c squared alone on the left side of the equation, and that equals these two terms that were added to the right side of the equation in the previous step. So a squared plus b squared. And here it is, the Pythagorean theorem we've been waiting for. And that proves the theorem is actually true. I hope you found this explanation interesting. And I'll be back with more interesting, more helpful, and more important stuffs in the near future. Thank you for watching the video. See you next time.